Now what we do is we learn how to use this branch instruction. Did you remember? Branch if register R is greater than 0, then go to a memory address, right? Location here, label. So that label is going to be one memory location. This instruction, second one, register indirect mode. So where in the register we are going to keep an address. On that address, if you go to that address, we are going to get the operand. Okay. So these two things, I'm going to use, and I'm going to use. I'm going to use to write a program. Let us do that. So example, my requirement is I have some n numbers, and I would like to add them. They are number 1, number 2, number 3, so on, number n. And I would like to add all of them. Already that values are mentioned in the numbers like this, 1, 2, 3, something. Okay, something like 7, whatever, doesn't matter. So we have to add them into sum. So sir, who keeps this n number 1, number 2, number 3 into this memory locations? Assembler will do that. For that we have separate instructions. I am not discussing them. They are very easy, but unnecessarily I don't want to dilute the topic. Our main goal is writing the logic part, okay, not defining these things. Okay. Now already let's say these values are stored in the memory. Your assembler can do it. Now every variable has a memory location. N is for us, like we will be using n, but it is corresponding to some memory location 100. I am assuming that everything here is integer. They are occupying 4 bytes. Okay, 100, 104, 108, 112, 116 in that way. Okay, sum is 120. Now we have to write remaining instructions so that all these values will be added. That is a separate story. To understand that, first we start with a simple thing. I would like to add first number to sum. How to do that? Let us do that. For that, what I am going to do is, first of all, I take that number because it is in number 1 memory location, right? I will take that into register. How to do that? Load that value into register 1. Let us use R1 for that purpose. R1, and where is that? I am using direct mode. So it is in number 1. Yes, I got it. Number 1. So after that, you have to add that to sum, right? So how to add it? But we have only store instruction. If you want to store something here, we have instruction. But before that, so the value to be stored is now what? Example, let's say sum is already having something 20. We have to add this number 1 to that, correct? So what I do is, otherwise assume that let's say it is already nothing. I mean I don't know what is this value. So initially I should assume that that is 0. If it is 100 or not, anything doesn't matter. I would like to add all these numbers 1, 2, 3, 7. Example, if you have to add 4 numbers 1, 2, 3, 7, answer should be 1 plus 2, 3, 6, 13. I should get 13, that's it, irrespective of the previous value. For that we have to write a code. I am showing that. So for simplicity, first we add only this number, later we extend the code to add a number 2, number 3, so on. For that what I am going to do is, I am using one more temporary register R3, otherwise let us say R2. The purpose of R2 is to remember the value to be stored in sum. Okay, so slowly you will understand why another register is required. So here this is not about loading, but taking another register R2 for the purpose. I am using an instruction called clear. Okay, so don't worry about this instruction. Clear, let's say an instruction which is going to clear a register. When you write clear R2, generally we use only for registers, then that register will be cleared. Assume that such instruction exists. Then what is going to happen because of these two now so far? So I can show pictorially like this. R1 is a register which gets a number 1. Second, there is a temporary register R2. On that we have a sum called 0, which I would like to store here. Now tell me the instruction for storing that. Directly we write this, correct? Store that R2 to sum, correct? Then automatically 0 will be stored. But actually what do you want to do? You want to add +1, right? That means, so before storing that R2 value into sum, we should add that R1 value into this one, correct? For that let us use instruction add R2, whatever, R2 comma R1. So already R1 contains 1, R2 contains 0, 0 plus 1, 1. Perfect. So sir, why are you doing these many instructions? Directly, why don't you take that R1 value and why don't you store R1 sum? Why this R2? I will tell you, because our goal is not only adding one value, right? We have to add 2, 3, 7. Now, sir, how to add 2 again? For that, can I tell you one thing? We should write one more instruction like this. Add before storing R2 equal to, because in R2 we are going to keep the result, right? Add R2 equal to R2 plus number 2, actually, correct here. I mean, just this is not a correct instruction, but I am writing like this. R2 equal to R2 plus number 2. Then again, third step we have to do, add R2 comma R2 plus number 3. This is what you are expecting. But where is number 2? Number 2 is in another memory location. For that, again you have to load R2, then load again R1 with number 2. This is what you should do. I show here. So add R2, R1 after this step. What you do is load again. Load this time your R1 with number 2. Then don't clear this time R2, but add that R2 equal to R2 plus R1. See the instructions. Let us execute these 1, 2, 3, 4, 5 instructions. What happens, we'll see. Load R1 number 1, yes. Clear R2, yes, R2 is 0. Add R2, R1, R2 plus R1, 1, which is added into R2, yes, perfect. Then load R1 into number 2, yes. That means number 2 is what? Load into R1 number 2. What is number 2? 2. Correct, 2 will be added here. Then add R2, R1, yes, R2 plus R1, 2 plus 1, 3. That we will be adding into here, right? I'm sorry, this is 2 itself. Then after that, you have to do one more thing. Load R1 with number 3, add R2, R1. So here slowly you understand that this is repeated, correct? Example, if you have 100 such numbers, are you going to repeat this instruction 100 times to evaluate it? That's a bad design, correct? So we need a good design of code. For that, what we need is, of course, because you have studied in C programming, we need a loop, right? So that's why here branch instruction is going to help you for that loop. Now we'll see the details. So what I'm going to do is, first of all, I'm going to take this number because this is important. Based on that, I'm going to write the loop, okay? So that's why let us take that n into some temporary variable, let us call R3 comma n. Now here, what is your final idea? I will tell you. So every time I am going to reduce this R3 by 1. Okay, initially let's say n value 5. So I'm going to write a loop, and that loop, so first time it will be 5, next it will become 4, then 3, then 2, then 1, then 0. Whenever it becomes 0, then after that I don't go back and I don't do addition process. We know one thing, we have to add, example, there are 5 numbers, here I am only showing 4. Assume that let's say there are 5 numbers, 1, 2, 3, 4, 5. Then we have to add 1, then 2, then 3, then 4, then 5. So only 5 times we have to execute some code, correct? For that we are going to use condition, branch if R. So that R is nothing but now this R3. So let me write it. So what I am going to do is, I am going to do some logic which is nothing but adding, correct? Add 2 dash R2, correct? Add to R2 existing value comma some extra value which should come from first time number 1, then number 2, number 3, so on. We will see that. Further we have to develop the logic. Then we write this loop, branch. Okay, so this is the start of the loop. Okay, here we are going to do the step, right? So let's say starting location is here, loop. So branch on if that register is what? R3, right? Okay, R3. If it is greater than 0, then go to a memory location called loop. So here this is called label. Now automatically, remember one thing, we are writing loop, but don't worry, assembler will convert this loop to one memory address. That you will understand slowly. At this moment, loop is pointing to one instruction. Okay, here we have to write an instruction. So what happens is, first of all, R3, we will start like this. Load R1 number 1, clear R2. So R2 is empty. If you see the picture, you can understand clearly what is going to happen. R2 is 0. Then what should happen is, so load R3 comma n, there is another register R3, in that we will be writing n, right? So n is nothing but content of n is n. Let us assume that that is 5 for time being. So there are 5 numbers to be added. Then how to do that? For that we have add instruction. But add R2, here what you have to add? First time number 1, at least first time we'll try. So we will be doing here R1, right? Already that number 1's value is in R1. Let us do this. When you do that, this is loop beginning. Okay. What is going to happen, we'll see. If you write loop like this, add R2, R1, what is going to happen? First time R2 equal to R2 plus R1, 0 plus 1, 1. Then branch, if R3, is this R3? And one more thing, because you added one number, right? You do one more thing, R3 equal to R3 minus 1. This is logic. Then how to do it in assembly level instructions? Subtract. Assume that we have a subtractor. For that we have instruction like add. That's quite easy to understand. So same syntax. Subtract R3 equal to R3 minus 1. R3 comma 1. Right. So 1 is not a register name, right? That's why we have to give in immediate addressing mode. So immediate addressing mode. Yes. Finally, what is happening is, first time R2 gets this value, then R3 will become 4. But 4, see here, content of R3, which is 4. Is it greater than 0? No. Yes, sorry, true. Then we will go to loop. So loop here. Then again add R2, R1. Then again same, R2 is going to get again R2 plus R1. R1 is initially 1, next time also 1, next time also 1. Then every time you are adding first number. Second time I want to add second number. Then what to do? This load R1 number 1 should become next time. I wish this. I wish second time it should become number 2. Third time it should become number 3. But why it will happen like that? Unless you write it. But every time if you change the logic, then you get lengthy code, right? To utilize the loop, the instruction should be common. That's why what we do is, we have a clever idea. This is the place where we use, this register indirect addressing. How register indirect addressing will help, I will tell you. For that, so you should know one more instruction. What is that? Is move instruction. Sir, you did not teach us move. I am going to teach now. Okay. So that's why. Based on the requirement, if I teach some instructions, you can remember them. Otherwise, you don't understand why sir is teaching move and why suddenly say sir is teaching clear, right? So that's why. Always the learning of programming language should be like this. You should be open for everything. And whenever a new requirement comes, you should learn the instructions required for that. Correct? Here your new requirement is, you want to take the starting address of all these numbers. Sorry, here. So what is my goal? I will tell you. I am going to take the starting address of all these numbers, which is 104. Then every time I increment this address, so that I will go to the next numbers. Let me show that. For that, I am using an instruction called move. Move is going to move some address to some register. Example, if I write like this, the syntax of move is like this. Move register to, here immediate addressing. We have to give some value. When you say move R1 and R2, R2 value will be moved to R1. Remember it. Second thing. So you can use move R1 with some like this 50. Then what happens? 50 will be moved to R1. Here, this is move instruction with immediate addressing mode. This is move instruction with register addressing mode. Correct? So let me use immediate addressing mode. Okay. Assume that we have such instruction. Okay. Move. What are we doing? We are adding R1. We are adding into R1 this address 104 directly. So 104. How to specify 104? Number 1. Now, since this is indicates that it is a immediate addressing mode, your your processor will understand that number 1 is a operand. Correct? So number 1. What is number 1? 104. If you want to take this one, what to write? Number 1. If you write this one, then what is the meaning of that? Number 1 will be moved to R1, but that is load instruction. Remember one thing. The difference between move and load is generally used to move some memory value to registers. Move is used to, move data from one register to another register, otherwise one immediate value to register. Okay, remember the difference between these two. So in load, one of the argument is from memory. In move, the nothing is from the memory, everything is from direct. So that's why let us use that instruction here. Move into R1. What is that value? That value is first time immediate value, that is number 1. So let us show in pictorially. So R1 contains now 104. Fine. Next clear R2. Then R2 gets 0. Then what is the third step? Load R3 comma n. So into R3 register, I would like to add a number called n, right? So this is now memory. N is memory. From memory we have to fetch this value. Assume for time being this is, let's say, 5. What is going to happen? This will become 5. Let us keep this value n here, but we assume that n value is 5 for easy understanding. Now next step is what you tell me. So here in the loop we are adding R2, R2, R1. Do we have to add R1 to the data? No, right? Here we have to take value of R1. Before this step I use another register. Slowly you will understand. Load always in the loop, first step. Okay, load into a register R4, which is nothing but R1. You will slowly understand what does it mean. If I really execute this instruction, what is going to happen? There is a register called R4. That R4 is going to, see, this is register indirect mode. That's why the purpose of our this entire program is how to use this register indirect mode and what is the purpose. See, this is the purpose of register indirect mode. See, what happens because of this instruction, first we'll learn. R1. R1 is not operand. If you go to R1, you get address, and if you go to there, you get operand, right? Go to R1. So what is there in R1? If you go to R1, then you get 104. Let us replace. That means it is like removing this brace. Whenever you get 104, it is like removing the brace. Now the conversion, now you can understand it as direct mode. Okay, go to 104. If you go to 104, which is 1, right? So that is about register indirect mode. Already we have discussed it, right? So it is like we mentioned generally in the braces, register number, right? What is the register number? R1. First of all, we have to go to R1. You get something. Then if you fetch that, that means one level of fetching is done. But still one more level of fetching. For that you have to go to 104 again. When you access 104, then you get 1, right? If you get it, that means you are doing register indirect mode operation. Then R4 gets what finally because of that? Because of that, R4 gets 1. So that means this is going to be added to R2, right? For that we have to change this add instruction, right? So add was R2, R2, R1, but actually now it is R1 is having 104. We would like to add 1, right? That's why we already moved that value at 104 to R4 that we can use here. Okay. Now loop begins here. Loop add R2, R2, R4, then subtract R3, R3 minus 1. It is as it is. When you subtract R3 from 1, so 5 becomes 4. Now let us execute all these instructions one by one and try to understand. Move R1, move R1 and hash number 1. What happens? Hash number 1. Number 1 means 104. 104 will be moved to R1. Perfect. Clear R2. R2 will become 0. Load R3 comma n. So into R3 we have loaded n. This is absolute mode. Then n will be the address. We will go to there. And you get what? 5. So 5 will be loaded into R3. Then load R4. R1, right? This is indirect mode, register indirect mode. In that, first access R1, 104. Take that 104 and access 104. One more access, 1. So that is a operand. So that operand we have to move to R4. Then R4 gets what? 1. Then this instruction, add R2, R2, R4. R2 plus R4. R2 is what? 0. 0 plus 1, 1. 1 will be added to R2. Perfect. Immediately subtract R3 equal to R3 minus 1. So R3 gets R3 minus 1, which is nothing but 5 to 4. Perfect. Then branch R3, 4. Is it greater than 0? Yes. Then go to loop, right? We have written loop. Then remember one thing. So whenever there is a branch instruction, then if condition is true, then destination will be, otherwise the next instruction to be executed starts at loop. That means, so instruction execution starts at loop. Did you remember? Already I told you, every time when you execute one instruction, program counter will be incremented. That I taught, right? But when there is a branch instruction, then program counter is going to take loop. That means program counter will be loaded with loop. Now everything is same. Because of that, now did you remember one more thing? How instructions will be executed? Fetch, execute, fetch, execute, correct? There is a fetch phase, there is a execution phase in a 2 level. Now while doing that, this instruction also will have 2 phases, fetch, execute. When you fetch it, so this instruction will be taken. When you execute it, this logic will be executed. So because of that, program counter will be updated with loop rather than incrementing by 1. Generally, if this is not the instruction, if other instructions are executed, program counter will be added +4 so that they will go to next instruction. But because of branch instruction, what happens? Program counter will not be incremented. Program counter will be modified by loop. That is the only difference between branch instruction and ordinary instructions. Okay. So because of that, now program counter contains what? Loop. Because of that, control goes here. Right. Now again add R2, R2, R4. Because of that, what happens? R2 equal to R2 plus R4. Right. Now check it out. If I do R2 equal to R2 plus R4, what is going to happen? 1 plus 1, 2. But do you want to always add +1? No. Next time 2, next time 3, that way. Every time you want to add a different number. For that we have to add an extra step. Once this, when we come to inside the loop, one more thing is to get the next time a different value, this value should be modified, correct? Next time we have to get different value. For that what we do is, we do like this. The one extra instruction, I clearly show that instruction here. Let me modify that instructions. What is that is, I make this 104 to 108. So if I do that, what is going to happen? You see, here in the R4, you are getting always value of R1, right? So this also should come into the loop. Let us write loop clearly. So loop is like this from now onwards. In loop, what should happen is, first, load as it is, load R1. So this is 104, right? Whatever it is. Initially, let's keep 104. Load R4. What was the instruction? Blindly copy it, R1. When you execute first time, you get what? 104. Value at 104, which is 1. R4 gets 1. Next time to get another value, R1 should be incremented actually. R1 should become 108. That's why let us add instruction. Add R1 comma #4. It is immediate mode. That's why 4 will be added to R1. If I execute these instructions, what is going to happen? We'll see. Start. R1 initially 104, number 1. R2 0. R3 comma n 5. Then loop in that. So load R4 comma R1. That means in R4 we have to write, right, indirect addressing. Because of that, into R4, first of all, value of R1 104. Value at 104 1 will be added. Next, add R1 equal to R1 #4. So that means increment R1 by 4. Correct? 104 plus 4, 108. Next step, what to do? So next step, what we have to do is, now we have to, add this R4 value. Let us add this R4 value. What is that? 1 into what? Where do you want to maintain the sum? We are maintaining that sum into R2, right? So add R2 comma R4 comma R2. Let us write that what? R2 comma R4. So addition is done. I got now 1 by this time. Of course, once addition is done, then what we have to do? We have to subtract this count, correct? So this is what? Register R3. So register R3 should be subtracted. Subtract R3 equal to R3 comma #1. Every time this should be decremented. Fine. Then we have to go to loop based on branch. So branch if of, what is the register name? Register name is R3. If it is greater than 0, then go to loop. Yeah, when you go to loop, what happened this time? Load into R4 R1, right? What is R1? 108. But it is indirect mode. then we'll go to 108 and we fetch number 2. Then this time R4 gets 2. Blindly follow the instructions. Now see, this is the idea. R1 equal to R1 hash 4. Whenever you fetch new value into R4, R1 is incremented. This time it will become what? 112. 188 plus 4, 112. Okay. Now, sorry, this one, right? Next, this one. Add R2 equal to R2 plus R4. Add R2 equal to R2 plus R4. 1 plus 2, 3. Perfect. Then subtract the count. So R3 will be 3 now. Then again R3. Is it greater than 0? Yes. Then go to loop. This time load R4. Load into R4. This one. Value at R1. Right. So what is R1? 112. So it is register and direct mode. We know that. Go to first 112. So when you go to 112, you get the data 3. Then 3 will be loaded into R4. In that way, if you continue this process, what happens? So R3, so this time again add R2 equal to R2 plus R4. This would become what? So it is not 3 here. So I mean already it is 3. We have to store that value into R4, right? Yes, we took that value into R4. Then this will become 112. Perfect. Then add R2, R2, R4. Add R2 equal to R2 plus R4. So what was the value in R2? 3, right? 3 plus R4. Blindly take value of R4. R4 is 3. 3 plus 3, 6. Then subtract. Then this will become 2. Then, so you need a lot of patience. You can execute it. I hope, when you do this looping everything, then finally R3 will become eventually 0, then 0 greater than 0 will become false, then we will go to the next instruction, whatever. You have to write that other instruction if you have. Otherwise, when there is no instruction, then we will be ending the program. At that time, program will be terminated. Okay. So this is the way, so we can write assembly level programming. Okay. Now here we learned so many things. What is that? Clear means it clears the register. And you understood what is move. Move is used to move data from register to register. Otherwise move data, some value from constant to, we can move constant to register like this. But remember one thing, move cannot be used to take that, move the value from memory address to register. Don't do that. This is wrong. Like saying move R1 and writing number 1. This is absolutely wrong. For that we have a load instruction. If you want to really take the data from memory and we want to write into register R1, we have to use load. That is the difference between load and move. In that way, so we can write sophisticated programs. In this looping, one important thing, if you see this step, every time load R4, R1. See this instruction, register indirect instruction. It's a fixed instruction. Did you change this instruction? No. But why it is loading every time different value? Because of indirect addressing. So R1 initially contains something, next time it is updated, then you are fetching the new data, correct? So using the register indirect mode, we can do this kind of stuff, right? So that is the usage of, I can say, register indirect mode. Now we will see some more modes like index addressing mode, base addressing mode, everything slowly one by one based on the requirement. Finally we will be able to, we would be able to sum some of the numbers. For that we have written a code. Okay.